everyone, and welcome to Unit 5B. Today we're going to start talking about polar coordinates and the polar grid. Today's lesson is starting on page 377 in your Springboard textbook. Now, on page 377, we see an example of a polar grid. And what a polar grid is it's a grid that's made up of concentric circles and rays from a common center. So you've possibly seen something like this if you think about, looking at like they have air traffic controller, or maybe I was thinking about like on a submarine, spinning around the circle and making that beeping noise. You see these polar grids. And really all that's happening is your entire mathematical careers, okay, maybe like 6th grade on, you've talked about, a coordinate plane, right? A polar grid is just another type of grid or able to plot points. It just has different uses than our traditional, X comma Y coordinate graph. Okay, so these are our polar grids. Now on page 388, we see here an example of the picture. So what's different, instead of being at like X comma Y like we are on our rectangular grid or with coordinate planes, what we are going to be at on these is R comma theta values. Okay, and what I mean by that is basically the radius of your circle length and an angle measure. Now, similar to how we've been talking about, circles and starting at 0 degrees on your initial ray, it kind of works the same idea as how we've talked about the unit circle and beyond. If we're going positive direction when we go counterclockwise, positive degrees, versus going clockwise means we go negative degrees around. And then just like on a coordinate graph, how you can scale, usually you're scaling by ones. Sometimes though, it might be advantageous for you to go up by 5s, or sometimes maybe you were going up by, 2, 4, 6, 8, how you can change the scale. Same kind of idea on our graphs here then, is that sometimes your scale might be different depending. So for instance, on this air traffic controller one, since we're trying to go out 30 miles, we don't want to necessarily go out by ones. They're actually going to have it where you can go out by 5. So each circle, you go out, it's 5, 10, 15, 20, so on and so forth. Okay. And again, there's some different vocabulary. We have our initial ray, we have different terminal rays inside us, and then again we have our polar axis, which positive x-axis versus y-axis. That's still kind of on here if you think about it as well. Like how we have x comma y. There's still that kind of idea there. And again, our polar coordinates are going to be in the form of r comma theta, which again stands for how far out radius-wise you are versus at what angle measure you are. Okay, and typically if we look at our graphs here, we're going up, like this one's going up by 30s, and again till you get to like 90 degrees. And sometimes though you'll see them scaled differently. This one's 30, 60. You get the idea. Okay. Now another way to look at these then, if you're plotting 50 miles out, 5, 10, 15, 20, 25, 30, 90, this would be your plotted point, okay, for that, if we were at 30, 90 or 50, 90, even further out. Okay, now on page 379, we see some examples of this. So again, they're showing us a point plotted on this example at 120 degrees and 40 miles out. And again, this is going out by 5s, so that's why we're out here 40. And then each time we are going up by 30 degrees. So it's like 30 degrees, 60 degrees, 90 degrees, and then this was the 120. So each of our little dashed here, we're increasing by 30 degrees. So what they want us to do then at the top of page 379 is graph these other points and write them as they would be identified as a polar pair of points. So if we want 20, 60, we'd be at 20, 60. So 60 degrees and then 5, 10, 15, 20 out. And then you would label this point A. Oops, this is supposed to be on this picture here. So here's point A. And then from there, we also have one that's at 20, comma, negative 120 degrees. So that would be going down. Negative 120 would actually be over here on this axis because we'd be going this way. And then 20 out, it would be B. And then 15, comma, 150, again, going back in the positive direction. 150 would be over here, and then 5, 10, 15 would be right about there. Again, anybody there, RC. Okay. Now, if we talk about the points 40, 240, or 40, negative 120, either way we talk about this, what we're going to see is that those 2 points are both here. If we go positive 240 around versus negative 120, we end up at that same point. Okay. They're at the same location on the polar grid. So this is unique to a polar grid versus our rectangular points x comma y on our traditional graph, because if I told you something was at 40 comma 20, there's only one 40 comma 20 on our graph. There's not another point I could say that would put the same thing. But polar graphs are interesting because you may have more than one polar coordinate at the same location. Okay, so that's something to be aware of. One polar coordinate at the same location. And again, the x comma y graphs, x comma y, these are going to be unique. There's only one point possible. Okay, they're a little different. What we're used to versus this new polar graph that might have different locations. And again, it goes back to way back to activity 14. Remember, I said so much that the idea of a coterminal was so important because it goes back to that idea that we can keep adding or subtracting 360 to these to get more equivalent coordinates, because we could be at 40 comma 600, and that would be at the same location, or you could subtract from this, from negative 120. Maybe you want to subtract 360 more, and you end up at 40, negative 480. Those are all officially at the same location, again, because of that kind of coterminal nature to our polar points. All right. Now, last but not least, the last big thing for today is what happens if there is a negative in front of your R value. Well, in order to convert this from negative back to positive, what ends up happening is you're going to take your theta value, and you can either add or subtract 180 to it to get it back to that location. So for instance, if I'm at negative 50, comma 30, that's the same location as being at positive 50, comma 210. Okay, so see this location here. And again, it goes back to either adding then 180 to 30, so we see that same location, or you could have subtracted the 180 and you would have ended up at negative 150, which again is this same point over here. So anytime they're giving you the negative radius value out front, you want to add or subtract depending on what makes the most sense in the situation to plot your point. Okay. So we finally have, and again, this is kind of something you might want to jot down because again, to convert, we want to finish out today by practicing, again, plotting some points, including plotting when we have a negative R value. So again, for number 4, I would recommend converting this to a positive 30 and doing so by adding 180 to the point. So 120 plus 180 would be 300. So really when I'm graphing negative 30, 120, it's the same thing as graphing 30, comma 300. which would be right here. So this is point A. Okay, or another way of looking at that is if you were at 120 over here, 30, it's like you're following across the line. Oops, 120 would not be there. Or to follow across the line to get there. Oops, so sorry. It should be over on this one. 2. So here's A, sorry. Because again, if this was at 120, you're kind of 180 degrees to the other side to be able to get that point, okay? Now the next one then, if we wanted to be at negative 45, 270, we'll make that positive 45. This time I'm going to subtract 180, so I end up at 45, 90, which is right here. Okay, so this would be our point B, just inside there. It's the same location as saying negative 45, 270. Converting this one then, we would have positive 30, and again, you can either add or subtract 360. This time not 360, excuse me, 180. So I'm going to take negative 210. This time I'm going to add 180, so I would end up at negative 30 degrees. So that's going clockwise down here. So 30, negative 30 would be right here. Here's my point C. Next, we have point D. Make this positive 25. Again, either add or subtract 180. This time I'll add the 180 in the positive 90 range. So 25, 90 would be right here. This is point D. And then last but not least, they want us to figure out if we have point E is at 20, 300. So 20, 300 would be right here. This is point E. What are 3 other ordered pairs that could work for 20, 300? Well, obviously, if we add or subtract 360 degrees for those coterminal values, that would make sense, right? We could add or subtract, so we'd end up at 660 or 20, negative 60 degrees. But again, we could also consider, okay, if I change this to a negative 20, I could subtract 180, or maybe I would want to add 180 to the 300. These are some other possibilities that you could have as an answer there. Okay, so again, having this fact down that you're adding or subtracting 180, if you're flipping your R value from positive to negative, very important. Okay, thanks everyone for watching, and we'll work more with these polar coordinates and graphing in class.